Hey YouTube, and happy Friday. Thank you all so much for watching my 256th YouTube video celebration and demonstration of how you can use your Digirule 2U that I'm showing you in the webcam view here to add two unsigned 8-bit numbers with carry. I'm so glad that so many of you watched that video, and also I was very happy to see a number of different viewers told me that they had Digirule 2Us and the video inspired them to do all sorts of cool things with them. So that's really wonderful. That said, as Nino Ivanov pointed out in a comment, the way I assembled the code was reminiscent of how people would do things in the 40s, 50s, and 60s. I did hand assembly using knowledge of the instruction set to convert from assembly source code up here to machine code down here. In this video, I want to show you a simpler way you can assemble source code for the Digirule 2U using one piece of software out of a whole software suite that Brent and Brad provide with the Digirule 2U. That assembler software is called ADR2. It's a Digirule 2U Cross-Assembler that I'll talk about in a second. In order to use it, I took this source code that I showed you in the video on a piece of paper and converted it to a format suitable for the assembler. What I want to do next is go through the user manual a little bit and just show you how I followed the user manual to reformat my source code. ADR2, as I mentioned, is a cross-assembler for the Digirule 2U, and it takes assembly source files and converts them to listing files as well as hex files that you can upload straight into the Digirule 2U. It supports the whole Digirule 2U instruction set. It supports directives for control of the assembly and listing process, definition of symbolic names to represent memory addresses and constants, symbolic expressions with a comprehensive set of operators, predefined symbols for commonly used Digirule 2U resources. Numbers represent binary, decimal, hexadecimal, and character notation, and it produces a formatted listing file that includes location counter, machine code, source line, symbol table, and RAM usage information. It's really, really nice. I'll show you the one that I generated from my source code. It does 2-pass assembly and directly produces machine code in Intel hex format for download to the Digirule 2U. Not really a binary file, but hex represented in ASCII that the Digirule 2U can take in through the USB-C port that you all can see there, which acts as a USB serial adapter when you plug it into your PC. It doesn't have too many options, just suppressing any information, not creating a listing file, creating a listing file, and showing help. And it's super simple to use. All you need to do is pipe in your assembly source code output or your assembly source code input and then pipe out an Intel hex file. You can also create a listing file with --list, as I showed you a moment ago. And if you plug in your Digirule 2U, you can output that hex code straight to the Digirule by piping to whatever device the Digirule 2U shows up as. I guess TTY USB 0, here just showing that you set using STTY the USB serial adapter to 9600 8N1 beforehand. Okay, and I'll go ahead to the next few pages here and show you information on how you format your assembly source file in order for ADR2 to properly assemble it. The assembler recognizes the following different types of characters. I guess the key thing is that each line has 4 fields separated by white space: the label, operation, operand, and comment fields. The label field and comment fields are optional, operation and operand aren't, but you have to make sure in each line that you specify these in order. So you can't exclude the label field altogether. You leave it empty, put in a tab or white space, and then operation field, tab or space, and then operand field. And for the operand field, you can't separate the operands with white space. They must be separated by commas. As you know, as I mentioned, this is a white space delimited format in general between the different fields. So two different operands separate with commas within that operand field. There's different directives that you can use. Constants, this is pretty important for how I reformat my source code. For hexadecimal, I changed everything to all the hexadecimal numbers to be prepended by 0x. If I want decimal, I just can enter those alone, and then for binary, 0b before the binary number. There's a number of different expression operators, predefined symbols, and then this just talks about the assembler output into a listing file, an example source file, listing file, and then that concludes the user manual for ADR2. Okay, so from there, I'll go ahead and switch to my original source code that I have highlighted in blue here. I'll show you how I converted it to a format suitable for the Digirule 2U Cross-Assembler. For my first line, I specified a label as main, just since there's no other procedures here. There's a single routine, no subroutines. And then I used a tab as white space to separate it from the operation field, and then a space and the operand for a space and then the two operands within the operand field. For these next lines, I didn't include a label, but you notice I do have a tab because otherwise ADR2 would just treat the operations or instructions as a label instead of a instruction or operation. So make sure that even if you exclude a label, that you have white space separating the empty label from the operation, otherwise assembly will fail. Anyway, you can see that's a pretty easy process. It's not very stressful. And before I forget, I should say one other thing I did between the two is I changed all numbers here from just 2-digit hexadecimal to 0x prepended for the assembler to recognize these as assembly values. And with that, I will switch over to the command line view and just show you how easy it is to assemble this source code. I'm in the Digirule 2U directory in my home directory. I've made ADR2 executable, and I've piped in the source code that you just saw. Output a listing file on the right here, and then piped the output from standard out into a Intel hex file. You can see that's very, very fast. We can see how big those different files are. As you would imagine, the listing file is by far the largest. We can take a look really quick at the Intel hex file that you can pipe into the Digirule 2U, about what you'd expect. And now let's take a look at that listing file. This is super, super cool. You can see at the beginning, the machine code and addresses separated by byte, which looks eerily similar. Let me put them next to each other to the machine code that I hand assembled here. Look just how similar those two are. That's really, really wonderful. Right to the right of the machine code, you can see the corresponding instructions and labels. You can see assembly completed with no errors and no warnings. These are positions of different registers, and you can see the first 15 bytes out of 256 are used. And that's really all it takes. It's an incredibly fast, easy process to assemble your Digirule 2U source code into an Intel hex file and into a listing with annotated machine code. Super, super easy. I'd highly recommend using this in the future. Speaking of the future, in a future video, I plan to to show you how to use the Digirule 2U simulator. I think there's a Java-based version that I've seen online, and that's nice, for tracing what each instruction is doing. I know Scott Haley is very interested in me showing more, input and output at each stage, like a trace kind of operation, as well as flow charts of this code. So I might include that as well with the Digirule simulator. And in addition to that, stay tuned for this Digirule 2U demo getting ported to the Nano Kenback 1 that I still have in a cabinet back behind me, and I really haven't played around with as much as I should. So I'm really looking forward to adding 2 unsigned 8-bit numbers with carry on that wonderful ruler-sized emulator of the very first personal computer. And with that, I appreciate your attention. If you have further thoughts about this, leave them in the comments down below. And please like and subscribe as always. Have a great one.